Okay, we're going to look at the next section now. So this is a fair bit more difficult because we're doing all the same sort of stuff as before, but we are going to be in situations where substitution is very difficult. So we need to use identities to create Cartesian equations. These ones here at the top of the screen, you should be familiar with those. They'll be coming up a lot. It's possible as well that perhaps another identity from elsewhere could be used, but those ones are really, really common. So a curve has the parametric equations x equals sine t plus 2 and y equals cos t minus 3. T is allowed to be any real number. So in other words, t could be basically anything. So how are we going to get a Cartesian equation here? So this is the thing that we are not going to do. So lots of people would be tempted to do something like this. They'd say x minus 2 equals sine t. So I'll do inverse sine of that, or arc sine it's called as well. And I'll call that t. Right, okay, the logic's all right, but here's the problem. Then you're going to have the other equation, cos t minus 3, where you're going to be substituting all of this in here. So what are you going to do then? Well, you're going to be stuck because you're not going to be able to manipulate this any further. So trying to get t on its own is not going to be the way forward for these ones. What we're going to do is we're going to stop at this point here. So x minus 2 equals sine t. And at the same time, let's rearrange the other one. So it says y plus 3 equals cos t. The goal is we want to link these equations together somehow, but we don't want to see this and we don't want to see this. So do we know an identity that has both of them in it? Because maybe we could use that to remove the problem. And the answer is yes. So we can use the identity sine squared plus cos squared equals 1. And we write that down and we get the sine squared piece ready, the cos squared piece ready. We substitute them in and we take it from there. So let's do that. This is sine t, it says sine squared. So I'm going to do that. So my approach for this is I like to get the pieces ready before I substitute them in. I need to do the same thing for the other one. So I need to square it to get cos squared t. And now, this one here, I'm going to change that to this substitution here. And let's use a different color, shall we? This one here, I am going to substitute with that part there. Okay. So what will I get? I will get x minus 2 squared plus y plus 3 squared equals 1. And that is a Cartesian equation. It's only got x and y in it, no t, no third parameter. Sketch it. Well, interestingly enough, you might recognize that's the format of a circle with a center of 2 minus 3 and a radius of 1. So you could just draw a circle. So where did we say it was? We said center is 2 minus 3, so it's about there somewhere. And in terms of drawing a circle, well, you would just make sure that it doesn't cross the axis. So you would, draw your circle on sort of there somewhere, and you would mark the center. Okay, that's all you have to do for that one. The trick is you've got to identify that an identity is the way to remove the third parameter from the question. Let's have a go at another one. In fact, pause the video here and have a go for yourself. My clue I will give you is that you'll want to use one of these here at the top. Okay, so we're going to use which identity? Well, it's got cot, it's got cosec in it. So the identity that we want to use is this one here that's in blue this time. Let's take a look. x equals cot t plus 2. So I could manipulate that so that I had cot squared. Cosec squared minus 2. Well, I've kind of almost got that. So let's get these pieces ready then. So x minus 2 equals cot t. If I square both sides, I will get x minus 2 squared equals cot squared t. Okay. Let's do the other one as well. So y plus 2 equals cosec squared t. Now notice that that one is already in the appropriate format. So I don't need to do anything further with that. So I'm ready to substitute that in. I'm ready to substitute that in. Let's do this. So 1 plus x minus 2 squared equals y plus 2. It says find the equation in the form y equals f of x. Okay, well, I take away 2 from both sides and I'll swap the left-hand side with the right-hand side. So I'm going to say y equals x minus 2 all squared. There's a 1 there, but I'm going to take away 2, so minus 1. So it turns out that it's this quadratic. If I want to draw this one, let's just see if there's anything else I need to watch out for before I do that. So t, you're allowed values between 0 and pi. How will that affect cot? Well, cot repeats every 180, so cot will be fine. This bit will be unaffected. How will this affect it? So it comes from a sine graph, doesn't it? So 1 over sine. So a sine graph goes up to 90 and then 180. So I'm only going to be able to get positive values. That's what this is telling me. So hence sketch the curve. So this question is definitely more difficult than it first looked. I'll just see if I've got a picture for you to help illustrate it. Have I got a picture? Actually, no. I do have a picture. I've just realized actually it's not a problem. So the reason why it's not a problem is you can only get positive values from this part, but it's going to be squared anyway. So you're not going to be missing out on any values that you would have had. So this is quite a niche point. But you are going to be able to have the full range of y values that you draw. So in this case, we can just draw this graph. So 2 minus 1 is the minimum point because this is a bit like completed square form, and it's going to be a quadratic, isn't it? Okay. If I expanded it out, what would I get? I'd get x squared minus 4x plus 4 minus 1, so 3. So it needs to go through 3. Okay. So that's what my sketch would look like. It would look something like that. So with the t value there, it wasn't a problem, but I had to just have a little think about how that might influence things. Because if you have quite a narrow restriction about t and you substitute it in with your trig, sometimes that will cause problems. Here it won't cause a problem, so I'm going to stop banging on about it. Okay, but just something to watch out for in the other videos. Let's have a go at another one. So this one, we're going to use a different rule to help us out. So a curve is defined by equations as follows. So what you need to notice here is that one of them says t and the other one says 2t, and that's not good. So that's not going to help us. So the sine 2t one is going to be the one to start with. So sine 2t and then t, what do you want to use? You want to use the double angle. So that's going to be the same as 2 sine t cos t. And now we want to use the other bit to try and remove the t elements of this. So this is a bit tricky, this one. Now x is sine t, so it means this bit, for example, you could substitute that bit out straight away. So y equals 2x cos t. The cos t, though, is a bit more problematic. So how can you remove this using the other equation? Well, if you did sine squared plus cos squared equals 1, then sine squared would be what? That'd be x squared, wouldn't it? Plus cos, let's put the letters in, plus cos t squared equals 1. So I could say that cos squared t is the same as 1 minus x squared, and then I could do the root of that. So I could say cos t equals the root of 1 minus x squared. Now, it's not pretty, it's not nice, but it does work. And I am using the other equation, and I'm using identities to remove this piece here. So I can do this. So the final answer for this particular one, for the Cartesian equation, is going to be as follows. Okay. Right, let's have a look at the next bit. So what's the domain? Well, to know what the domain is, I can take this restriction about t and I can substitute it in the x equation and find this out. So the rule for t is it's between minus 90 and 90 inclusive. So what happens if I put those values into sine? Well, we could do this by thinking about a sine graph. So minus pi over 2 and pi over 2 with a sine graph, well, those are the values that give you minus 1 and 1, aren't they? So you're going to get values between minus 1 and 1. That's what's going to happen. Okay. If you put the t values from minus pi over 2 to pi over 2 in a sine graph, you will get the values from minus 1 to 1. So that's your domain. How about the range? What's the range? Well, we do the same thing, but with the y equation. So if you put these values in, what are you going to get for y? Well, in general, if you put numbers into a sine graph, what's the best case? The best case is you're always going to get between 1 and minus 1, aren't you? It doesn't go any further than that. You can't get any numbers that are bigger than 1, and you can't get any numbers that are less than minus 1. So is it just the same? It might just be the same. It's got 2t, hasn't it? So minus pi over 2 becomes minus pi, which would be sort of up here. And pi over 2 times 2 becomes pi, which will be here. So in other words, what it means is when you put the values of t into this y equation, you're allowed anything across the sine graph, across this bit here. So that means you're just going to get the values between minus 1 and 1. Okay, if you are allowed any values from there to there, what does it range between? It ranges between minus 1 and 1. So the x bit and the y bit are almost the same question in this particular one. So that's your domain, because your domain is about the x values that you're allowed, and that's your range, because your range is about the y values that you're allowed. Pause the video and have a go at this one here, because it's quite a similar question. So it'd be a good one for you to do. So pause the video, have a go at this question here. So I'm going to assume we've done that. We've got double angle again. So we've also got a choice with this one, because cos 2t has 3 different forms. I'm going to pick the form that has only sine in it. So it's not 2 minus 1, it's 1 minus 2. So I'm going to use this result here, basically. So how do I want to do this? I think I'll rearrange this x equation first. So x over 2 equals sine t, which means that x squared over 4, so I'm squaring both sides, is equal to sine squared t. Let's write this out so I can just keep track of what's going on a little bit more then. So 1 minus cos 2t, and I'll leave the 1 as it is. I'll leave that as it is. Let's substitute the cos 2t. So cos 2t is 1 minus 2 sine squared t. And I could simplify that. 1 minus 1, the number's going to disappear. Minus minus is going to cancel. So y equals 2 sine squared t. And then I'm going to substitute in my other result. So my other result for sine squared is that it's x squared over 4. So my final result then is going to be y equals x squared over 2. That's my Cartesian form of it. Okay. What's the domain? It's asking me. So it's a sine graph between 90 and minus 90. Well, it's everything then, isn't it? Between 1 and minus 1. So it's like the question before. So it's minus 1 to 1 would be the domain for that one. Okay, so that's how you do that part there. Right, the next bit is we're going to do some sketching in the next video. So just to recap what we've done so far, we've said that with Cartesian equations, sometimes when you, instead of substituting with t, what you want to do is you want to use a trig identity or the double angle rule or something like that to try and remove the third parameter. Also notice that the idea of domain and range is getting more complicated again, because you have to think about if you are allowed any of these values in, what's the sort of the full extent of values that you can have out. Okay, so that requires you knowing your trig graphs quite well, really, in order to be able to draw that.